So in this video, we're going to do t-test of independent means for hypothesis testing. So let's have this problem. A tax collector wishes to see if the mean values of the tax-exempt properties are different for two cities. The values of the tax-exempt properties for the two samples are shown here. The data are given in millions of dollars. That's why this would mean 113 million, this is 82 million, and so on. This is supposed to be at alpha equals 0.05. Is there enough evidence to support the tax collector's claim that the means are different? So that's the claim. The means are different. So let's analyze this problem. How is it that this is for t-test of independent means? There are many different ways wherein t-test of independent means is called. Sometimes it's called t-test of independent samples, or sometimes it's the other way around. Independent means t-test, independent samples t-test, and so on. Now, the only thing that we would need for this is that there are two groups. We're going to adapt t-test even though the samples are greater than 30 or not. So we're going to adopt t-test as long as we have two groups, and these groups should be, of course, independent of each other. So as we can see, we're comparing two cities, and that is city A here and city B here. So since we're comparing for two cities and these two cities are independent of each other, then we're good that we will use t-test of independent means. So now we can proceed to our steps of hypothesis testing. Step 1 is of course our null and alternative hypothesis. So first, let's look at the claim. The claim is this. The word claim is there, that the means are different. So when we say different, they're not equal. So the mean of city A is not equal to the mean of city B. And since this is not equal, this should be our alternative hypothesis, that the mean of A is not equal to the mean of B. Therefore, our null hypothesis would be the mean of A is equal to the mean of B. So that is our step 1. Let's go to our steps 2 and 3. So now in steps 2 and 3, we shall now use Excel. So we will now go again to our data. There you go. And we have again data analysis here. And there we go. So let's take a closer look at our page here. There we go. Oops. So let's take a closer look at our data analysis here. There we go. Let's move a little bit. Alright. There we go. So here, as you can see, we have actually 3 t-tests, and we have seen this before. We have t-test paired 2 samples for means, t-test 2 samples assuming equal variances, t-test 2 sample assuming unequal variances. Now, the paired 2 samples is what we had in the previous video as for the dependent samples. So the other 2 is what we will use. T-test 2 sample assuming equal variances, t-test 2 sample assuming unequal variances. Question is, which one to use? Here, as you can see, we need to determine whether the samples are assuming equal variances or unequal variances. Hence, we will need to do a different test, and that is this one. There you go, f-test 2 sample for variances. So when this is the test that we will do first before the actual t-test. So once we have this, we'll click OK. So here's are the things that we would need. So let's have variable 1 first. Oops. Let's zoom out. So variable 1 is here, city A. Let's select that. Because that's the first one given, let's make this as our variable 1. There we go. Next, variable 2, we would use the second one given, which is city B. Alright, the labels are with them. It says here that alpha is equal to 0.05. The output range, I will choose first this one. When everything seems okay, we click OK. So first, before we continue, we need to check which variance is actually higher. So let's take a look at our table. Let's go down a little bit. There you go. As you can see, we have the mean of city A here and the mean of city B here. However, as you can see, the first data that we used for city A for variance is lower than the second one that we use, city B. And because of this, we would need to do this again. Why is that? Remember that if we're talking about this test, f-test of variances, oops, sorry about that, wait a moment. There we go, variances, which is actually that one. If we're talking about this, then please do take note that we would need the first variance to be higher. That is the rule of this subtest. It should be higher or bigger. So therefore, since what we use as the second variable is higher than this one, we would need to repeat at this f-test. So let us clear these writings first so we have a clear space to redo our f-test. So we will do the same, data analysis, f-test again. This time we will select variable 1 for city B because it has a larger variance. Then variable 2 for city A because it has a smaller variance. Then we shall select this one here. And now we have a different test. And let's take a look at our test now. Generally speaking, if the p-value for f-test is actually less than alpha, then we will use unequal variances. However, if the p-value is greater than alpha, we will use equal variances. So let's take a look at our p-value for our f-test. As we can see here, our p-value is actually 0.00013. If we're going to round this off to 2 decimal places, this is almost 0. So, since our p-value is almost 0.00, obviously smaller than our alpha of 0.05, then we will use unequal variances. So later on, when we're going to use t-test, we would need to use unequal variances. And we will see that in the next video.